Now I'm gonna share my screen. Okay. Yeah, looks like everything works better on this other computer. So this is great. Let's see. Okay. All right. So now we're back to normal. All I had to do is just change another computer. It's good I had just obtained a brand new computer, so it seemed to work just perfectly fine and it records, so that's all I need. So anyways, thank you so much for being patient. And last time we were supposed to have a class, but that was a holiday, Monday, President's Day. So I hope you recharged and enjoyed. And then we moved to the story of angles, right? So angles, and we're not going to use protractor tool, but we're going to see so-called supplementary and complementary angles. So angles that produce right angle, and it's important that we have this little box are going to be called complementary. See, with this computer, I have a hard time to write because the one I used to have, the one that I actually have in front of me, and for some reason it decided not to work with the zoom, is awesome in terms of writing. And here you see complements. I'm trying to produce complementary angles and having a hard time to write words with. And that's standard. Lots of computers have very soft cursor. So if I have, let's say, angle A and angle B, then there's some of A and B to be complements need to be what? A plus B need to give us 180 or 90. Well, what's going on? Let's jump. Okay. Let's just jump. Yeah. A plus B will give us 90 degrees. So that's a definition that is good to realize, that complementary angles added together produce 90 degrees. I will try to adjust this cursor for just in case after class that I might succeed, but not as well as in the other computer, of course. So 180 degrees angle, or so-called straight angle, that produces also two angles that are complementary. So supplementary and complementary. These are actually supplementary angles, and their sum is equal to what? 180, right? Straight angle, the sum of two angles, 180, straight angle. So supplementaries, I'll try to write supplementaries. That's long to write. So supplementaries, and complementary. So for complementaries, the sum is 90. No others. The good news is no others. So we just saw a few exercises like the one, actually we saw just one exercise, so the 28 and 62, and that was for the complementary angles or complements. Complements is another name, supplements, complements. So how about example on figure 10.9, where they looks like dealing with a pair of supplementary angles. So they say one is x plus 66. In other words, 66 degrees larger than the other angle. So the other angle is probably a little bit smaller. And then the one we have is 66 larger. So it'd be 66 added to x. I hope it's 66. So anyways, when you add those two, please notice you will add x with x, and that will give you 2x here, and then 66, and that's equal to 180. And then you'll be able to simplify or actually solve a little equation, and that will, that will give us 2x is 114 and 1x is 57 because twice 57 is 114. And that's not it. Whenever you're solving word problem, remember you always want to see what they want. And they want here two angles. So you just found one angle, you found x. But to get the other angle, you need to use that x and add 66. So not surprising, you need not to hurry. That's the key idea when you do math. Don't try to be first. Try to be correct. And I don't mind if you're gonna get it tomorrow instead of today, as long as it is correct. So there are other kinds of pictures in here, and the one that I have right now is dealing with the opposite angles that called vertical angles. So they put pairs of vertical angles and they say they're equal. So vertical angles are always the same. So opposite to 1 is 3. It is the same, as well as another pair of vertical angles such as 2 is the same as 4. So that's great to realize, and that's new definition. So the opposite or vertical angles. Very popular for the exercises. So you could do some nice little problems here now. So you can try to find all of those 4 angles that remain. And the one you can find right away is vertical angle. Turns out it is very convenient to see what's the opposite to 68, and that will be angle 1. It is also 68 degrees. And that's great. It is also 68. And how about angle 2? Well, it turns out that now we can use supplementary angles fact. So I could subtract that 68 from 180. Why can I do that? Why can I subtract? Well, because if I look at the half of this picture, so if I just copy here angles 2 and angle 1, I'm sure you're gonna see the supplementary angles, right? Because together they give us half of rotation. So this looks like 100 and what, 12 for the measure. I say, Alex, I saw this 112. It is indeed in here. Yes, but the good thing to realize is that 112 will also be on the bottom, right? 112, of course, degrees. Degrees, there's a little symbol. It's degrees, because one say, well, 112 of what? Well, these are all little circle above, so it stands for number of degrees. So it has to be everywhere and here. And that way I was able to find all 4 angles on the picture, just knowing one. And one can say, Alex, what I did, I first found angle 3 and then I found some other angles. Yeah, you're free to start your problem any way you like. In fact, the problem is nice, or I don't want to use word easy, but pretty straightforward if you can do it one way or the other way. So basically, any way you start, to do the problem, you will get the nice answer. Because hard problem is you have to tackle it. You start one way and can't solve it, then you try some other ways, and eventually you will find the correct way to work it out. Well, another thing they discuss is parallel lines, lines that do not intersect. They parallel when they don't intersect with each other, but they're still in the same plane. So we're talking about lines in plane. And with these parallel lines, we can produce 8 angles, and they show it very nicely on the figure 1013 down below. So there are 4 angles in one joint and 4 more angles in the other joint. And that's interesting, right? So we have parallel lines with bunch of angles attached. And please notice there are actually 2 angles only that turns out angle 2 is the same as angle 3. And then turns out angle 6 and angle 7 are also going to be the same. And they're all going to be the same. See, I have a hard time to write on this new computer. I'd rather have the old one, but the one like we're using for this class, because the computer I'm using right now to teach this class, I've been using so far, is probably more than 10 years old and it's falling apart. But it is working just perfect. The cursor works so well, so I can write things down very neatly. It follows what I try to write, but this one I really have a hard time. But anyways, so it turns out the angles 3 and 4 are also the same, 3 and 6, sorry, 3 and 6. And that makes 4 angles to be equal, 3, 2, 7, and 6. They're all the same angles, and sometimes they use word transversal angles, so they're on the other sides of the line, so they transverse. In other words, if I knew, let's say, angle 2, I would already know 4 angles and they'd be all of the same measurement. How about that? And also turns out angles 1 and 4, the ones that opposites, right? 1 and 4, trying to mark 4, as well as 5 and 8 are also all 4 of equal measure angles. That's why I'm saying there are really 2 measures only for all these 8 angles. How about that? So I try to mark it with red, these 2 opposites, as well as the other 2, 1 and 4, also equal. And that's quite amazing. So lines need to be parallel for that. That's the key idea that they have. So I guess that's a little bit of geometry. I know nowadays it's not very popular course, but we used to teach geometry and that was quite interesting. Lots of logical proofs in there. So it was, I think, very neat course. So anyways, now we can use the ideas of that to put them together and to find measurements of various angles. So I can use this supplementary, complementary angles, usually supplementary, and calculate all the angles that they have on this particular picture using knowledge of only one of them. But turns out right away I know they will be the same. So if that's 35, so this will be also 35, right? Angle which is opposite to it is also same measure, 35, as well as angle 2 and angle 5. They all gonna be 35 degrees. 35 degrees is one measure. So the question is, what be the other measure? So what I'm trying to do is to put angle measured 35 here. and then we'll utilize this idea to find its supplementary angle. Supplementary, that should give us a sum of 180. So what will be the supplementary angle? That's 35. I'm trying to hit this in the right spot. 35. So I need to subtract from 180, right? Take 180 and minus 35, and that will be the measure of other four angles. How about that? So if I take away 35 from 180, is that going to be 145? Right? 145, that'd be second measure involved in this picture. How about that? 140. Okay, so we have four more angles also found. This is worth to think about over the weekend. Please notice you have another weekend, you face another weekend. How about that? Wow, right? That's great. So the angle story, I think there are nice exercises. So this one I skip. I want to go to exercise set and look at some more beautiful angle exercises. I think they should be here. Let's say an exercise 27. Exercise 27, please notice that we need to find another few of those angles, and I will utilize the fact that we have a little box, a square box in this picture, which means we have 90 degrees angle. So the opposite angle to it is also going to be 90. Angle 2 is what I just found. And that's a great start. Again, you could have started some other place. For example, you could have started with complementary angle to 40, right? So there is another pair of angles that I just singled out, and that's angle 1 in here. And that angle 1, in fact, we put angle with it. So that way I know it's angle 1. And should that be 50? Because the complementary angles is what we're working with. And say, Alex, how do you know they're complementary? Well, since these two lines intersect at 90 degrees angle, so the opposite is going to be 90, and then two others also going to be 90 because straight angle idea, 90 and 90 is 180. So everything is 90 degrees measured. And that's why we found angle 1 was a measure of 50 degrees, right? Angle 1. And then notice the angle 3 is its opposite again. And it's also same measure of 50. So the point is, do not hurry. Try to pick on one of these angles and everything will just move on a little by little and you will get the rest. Okay, okay. So I hope you are enjoying it, and please notice it has absolutely nothing to do with what we did so far. And that's, I guess, the beauty of this class. If someone does not like one chapter, fine, don't worry. Say, some people say, I don't like logic, or we might eventually hit some number theory stuff. No worries. You may just skip it and you will still get good grade on the class. Just wait and we will get there. So let me try another exercise. I'll clear this mess and enjoy exercise. Here, it's actually entire group of exercises that want me to basically find various angles here. So they say use the figure, Alex, to determine if this is true or false. Please notice they kind of related to logic ideas that we already saw previously, true or false. So it's 35, correct? Is measure of angle 2 going to be 37 degrees? I say, what? Is it 37? Isn't that 53? Because it's opposite 53. Okay, so you put not correct, which means false, and that's it. I say false. You don't put 53. No, they want a false, so make them happy, put false. So I can try number 38 and see what else is here. So 38 is dealing with numbers, with angles 3 and 4. What do you think about those angles? Are they going to be the same? Are they transversal angles? Remember, we have transversal angles that are equal. When we have two parallel lines, right? And then we intersected by so-called transversal, and then the angles inside will be the same. But lines must be parallel. And my lines, no way they're parallel. They're not parallel. Right? Here they're not parallel. They're not the same. 3 is not same as 4. Okay, so another false statement. How about that? Another false statement. So that's pretty odd. They usually ask us to find the angles. Well, I think you cannot really find those angles, but because you don't know some measurements, all they can ask possibly is if it's true or false. That makes exercise different. And again, it makes us realize that we need to read their questions. That's important that you spend time reading. So with geometry, I hope you enjoying it, and I will see what else is here. So I'm gonna go back to there is one more big fact, the total sum of all angles in triangle. I think that's the one I need to look at now and finish this story. So I think it should be next section. Oh yeah, triangles. So it turns out there is a amazing fact, and they nicely shown it on figure 1015. So I can maybe clear this mess. Let me stop sharing it and then share it again. All right. So the sum of all angles in triangle is equal to 180. So if you take these angles 1, 3, and 5, or they say angle A plus angle B and plus angle C, they total to 180, which is quite amazing because it doesn't matter what triangle you are dealing with, the sum of its angle is always the same. It's always 180. And of course, they're trying to justify this using previous section idea of transversal angles. So they say here that angles such as 2 is the same as angle 1 because we have two parallel lines. So in order to show that, they put parallel line to the base. So this line that passes through the vertex of my black triangle is parallel. So that's what makes 1 equal to 2, as well as there is another pair of equal angles produced. That'd be angle 4, which is the same as angle 3. So since they're the same, I can say angles 1, 5, and 3 and triangle will be the same as if I take instead of 1, 2, instead of 3, 4. So the sum of these 2, 5, and 4 is 180 because the total is actually my straight angle. And that's interesting. That's quite amazing. And it's definitely worth to think about. That's very neat justification. So that's what they're doing here. And now exercises. So we can practice, we can do a couple of problems with these triangles, and that would be good enough. So example 2 is here. We have triangle and the pair of angles in it, 2 and 3, that are the same. Right? So what they want you to do is locate measures for all of these angles. So 2 and 3, we already know are the same. So what are they? Well, looks like I can utilize triangle with angle 1 because we have a right triangle here. We have a box, so it's 90 degrees angle. So I can see that angle 2, so I can put an arrow, will be measured 180. Subtract both of those angles that we already have in this triangle. So if I subtract from 180 angle that is measured 90, oops. So if I subtract 90, and then if I subtract, so if I subtract 90, it'd be 90 remaining, and if I subtract 43, right? So if I take 43 and minus it as well, it'd be giving me 47, right? It's such a hard time to write this. No, it doesn't want me to continue, I guess. It just says, Alex, enough. No, with 47. So measure of angle 2 is 47 degrees, right? So the same as for angle 3. So there are two angles that I found during this procedure, angles 2 and 3. So I can try to copy a little bit bigger picture of angle 3, which is 47, and angle 60. That's another angle in that little triangle, 60 degrees. They gave it to us. It's on the top, right? 60. And again, now I'm using the new fact, the sum of all three angles is equal to 180. So to get the third, to get the last angle in this little triangle, I need to take away this 60 as well as 47 from my 180, and that way I will get the remaining 60. Trying to put zeros is hard. It's jumping. It's just wants to be free. It just wants to jump. How about so it looks like I got 107 that I subtract from 180, and as a result I'm gonna get 73, I think. Yeah. Please double check. 73 degrees for the last one. Okay, that's good. I found the last angle, but I need to get angle 5. So how to get 5? Well, now I'm going to use angle 4, which is supplementary. So their sum is 180, 4 and 5 total to 180. So I need to take away from 180, that's 73. And we'll be done. So that will be 100 and what? 7? And that'd be the answer. Oh, and that's it. That's good enough for today. It's really a good practice for my patience. I think I really appreciate this Zoom thing that did not work. In fact, it might start working right now because remember, last Monday it decided not to work. It said, "Oh, it's Monday. I don't want to work." And again, it's again. Oh no! So Wednesday didn't work. So another Wednesday it doesn't want to work again. So let me try to log into Zoom from that other computer just for fun and see if it's going to actually. Yeah, it is. It is. Look at that. That's what I told you would happen last time. So now I'm able to log into Zoom. Do exactly the same thing at 9:50. Oh, sorry. Yeah, it's 11:50. 11:50. It's not working. It's not working at 11:50, but afternoon, it's fine. It starts to work, and I just logged into Zoom, and now I'm gonna be, I guess, ending this class anyways. All right. But thank you so much for being patient, and I guess I'm gonna stop this pain. So, and